Okay. So we will start with the lecture. So we have up till now in previous lectures we have covered these basic concepts. Vision mission we have seen. Then we have considered please come on the first bench. Yourself. Sit. So we have seen this basic structure or basic picture of optical fiber. Okay. Then all these things we have considered yesterday. Central idea of subject, importance of subject, title of subject, and syllabus we have taken overview of the syllabus. So that how many chapters are there? 6. So introduction first, then second. What is second chapter? Transmission characteristics and optical joints. Third one it is optical sources. Okay, so I will just open this. This one is overview, first chapter that we are going to start today. Then second, transmission characteristics of optical fibers and optical joints. Third, optical source. In that we have to see two sources. Optical means laser and LED. Source is converting the electrical signal in the form of light. Then optical detectors. That is fourth chapter. So that is covering these 3 types of optical detectors. Photodiodes, PN, PIN, avalanche photodiode, and last one it is the photo transistor. Then optical network, that is the chapter number 5, and 6th it is the optical fiber communication system. And practicals we will discuss more during the practicals. Okay, so this is about syllabus of this subject. Now we will start with this chapter number 1. Okay, so before we start, if you see the syllabus, now we will focus only on the chapter number 1. So introduction of optical fiber communication. So what you are going to see in this chapter, that is basically introductory things you have to understand. So if you see here, first we will see how the optical fiber that got developed in some year wise, की कुठल्या year मध्ये काय development झाली optical fiber ची, that we will consider. Then optical communication system, general block diagram of optical communication system, that we have to see, that is very important. Then advantages and disadvantages. Basically these 2 points we will try to cover today. So as I told initially, we will go somewhat slow for the initial chapters, at least for chapter number 1. Then for once you understand the basic concept, we can go somewhat fast as per your convenience. Okay, so I will go to this PPTs, and once we cover this basic part, then we have to see basic working principle of optical fiber. So for that I have requested you yesterday only to go through the basic part: refraction, reflection, refractive index. So how you define refractive index of any media? Suppose glass. Or first tell me, what is refractive index of air? Refractive index is there for let it be solid, vacuum, or liquid, any medium. For any media, the refractive index is there. So can you tell me what is the refractive index of air? Can anyone tell?
1.00003.
Yes, 1.0003. That is correct. Can you tell how you have how we can calculate that? Yes, Audumbar. Okay, so just that will be the homework for you. You find out the formula for calculating the refractive index of any material. And from that formula, you tell me 2 questions I will give you.
Ma'am, C upon V.
Yes, yes. Okay, Audumbar. Okay. I will give that as a homework for all. So I will give you basically 2 things. First, you find search for how to find out refractive index of any media. What is the formula for that? And once you get that formula, next you tell whether the refractive index of any solid media is greater than 1 or less than 1. So, and with justification, you have to give the answer. Okay, so because that is basic things, what you have already seen, because that will be required in this ray theory of light. In this chapter, the ray theory of light is very, very important for overall optical communication. If you understand the ray theory of light, then only you will be understand the various points which are based on the ray theory of light. Okay, so that part we have to see. So just 1 minute. Okay, so introduction already we have seen. Optical communication means what? What are the elements that we will see in detail in the block diagram. Okay, and then historical development. So I will go with this general slides. हिस्टॉरिकल डेव्हलपमेंट मध्ये काय येईल बघा आता जसं मी सांगितलं तुम्हाला की फॉर एनी करंट एक्झिस्टिंग सिस्टीम द प्रोग्रेस इज स्टेप बाय स्टेप. It is like we can say it is like analog system. It is not digital directly from 0 to 1. Step by step there is increase in every invention, and same it is applicable for communication also. So if you see the history of this communication, not only fiber but general history it is given here. So open wire system, what was the trend for the development, how it got developed. So open wire systems were used initially, then coaxial cables, ultra high frequency systems, microwave system. These are just general things. Now, from exam point of view, there will not be any question, but just for your understanding, you can go through that. So first बघा आता इथे open wire system होते आधी. So till 1950, the long distance voice communication was almost entirely transported over the open wire carrier system. Then, so here the picture it is shown. Then next there was coaxial cables. So coaxial cable and open wire system मध्ये काय फरक आहे? So these were not having more protective coatings, whereas as compared to this, ह्याचं जर स्ट्रक्चर बघितलं तुम्ही तर बघा तुम्हाला इथं फक्त हे मेटॅलिक दिसतंय and it is more covered with the protective layers. So as compared with this open wire system, these coaxial cables were useful for long distance communication and various in atmospheric odd conditions also it was suitable for long distance transmission. Then this was the ultra high frequency systems. So that was the next trend. Then satellite systems are there. So satellite it is basically using the uplink and downlink. Uplink means from Earth. Suppose you consider that projector as a satellite. So if this is Earth station, this will act as a transmitter. So initially we have to send some signal from transmitter to that satellite. It will process that signal and again send back it to the another Earth station. So that was the so from this first Earth station to satellite, that is called as uplink, and again satellite to another Earth station, that is called as the downlink. Okay, so this is about that. So here general description it is given: wireless communication versus wired communication. So wireless means what? Can you tell me any example of wireless communication? Mobile it is there. Then what? Bluetooth. Okay, so when that signal is not transmitted through any solid media, so that will be obviously the wireless communication. So infrared communication, आपण टीव्हीचा रिमोट करतो ना ऑपरेट. So whether it is having some wired connection? No. So that is done through the infrared waves. Infrared rays which are not visible to our eyes. Okay. So here is just advantages and disadvantages of wireless and wired communication. So just additional part it is there. You can go through that particular just for your information. So here it is comparison versus satellite and fiber optic communication. So That is additional part. Now this is the historical development in the optical communication. Directly there was no invention of optical source or optical detectors. Now whatever you are seeing, that is coming or that has come from lot of research and lot of experimentation in the optical field. Okay, so initially in 1790, this optical semaphore invented by this cloud. So initially this device it was invented. Then 1880, photophone invented by Bell at Washington. So these are all the historical optical devices. Then 1940, optical guides reflective coated to carry visible light. So waveguides were used in order to carry the optical signal. Then in 1960, this laser was invented by this Maiman. Okay. Then 1963, unguided communication with laser. So then after that, it went on through the various research and the various optical devices were developed. Optical joints are there, then optical sources, optical detectors, optical couplers are also there. So that all that is there in this that subject, advanced light wave communication. I told you, no, that is for MTech level subject. त्याच्यामध्ये सगळ्या advanced devices चा study आहे. But at this level for you at third year, you are having only optical sources and detectors. Okay. And then 1966, this optical fiber was invented by Corning glass researchers. Okay, so here is picture of that scientist has been shown. So basically, as we discussed, so this is just historical, year wise it is given. Then again, material which is used for development of optical fiber. What is that material I told? For coaxial cables, what is the material? For coaxial cable, this wired communication, electrical signal transmit करायला कुठलं cable वापरतो आपण? What material is used?
Core and cladding.
No, core and cladding that is there for optical fiber. Initially I asked for our regular wires, जे आपण आपल्या TV साठी वापरतो किंवा for our household domestic applications.
Aluminium, copper.
Copper is used as a basic conductive material and that is surrounded by protective coating. आपण बघितलंय analog communication च्या channel मध्ये. But here for optical fiber, whether we are going to use copper use करतो का आपण optical fiber manufacturing?
No, ma'am. No.
Yes. Then which material we are using for fabrication of optical fibers? Yesterday I told, no, two materials, basic materials used for optical fibers. Glass or plastic, but mostly we are considering glass, and glass is nothing but it is called as silica. So material for fiber was fused silica. Fused silica means that is in the ultra pure form. That's a fusion hoto. It is heated up to large temperature in order to purify it, and after that it is frozen and converted in the solid form. Actually in the previous syllabus there was one separate chapter, fabrication of optical fibers. At that time theory was there for 100 marks. So when it reduced, that chapter was eliminated. But that was having all the fabrication methods of optical fibers. Now suppose glass you have to first manufacture, no? Let it be for core or cladding. You have to manufacture first glass. So for glass manufacturing, first it is manufactured in the form of liquid, and after that it is frozen up to, means it is freezed, temperature it is reduced, and then it is converted in the solid form. So you know that process. For converting any element from liquid to solid, we have to freeze it and then it will be converted. So like that. So material which is used, that is silica material. It is used for manufacturing of fiber. Silica is nothing but it is glass. मग कुठल्या क्वालिटीचं लागतं, or what properties should be there? It should be extremely pure. If there is some impurity present in the basic material, then that is resulting in the losses. So I will give you simple hint that you remember. For whatever is the loss of fiber, loss of information when it is passing through the fiber, when you will see that point in second chapter, for all losses, if you give the reason as impure material during the manufacturing or fabrication process, that will be most correct answer usually for all the type of losses. कारण प्रत्येक लॉसेस मध्ये जर फॅब्रिकेशन करताना ग्लास प्युअर नसेल किंवा त्याच्यामध्ये जर काही इम्प्युरिटी प्रेझेंट असेल तर दॅट इज गोइंग टू रिझल्ट इन द लॉस ऑफ light passing through the optical fiber. So that's why that special properties, first property is extremely pure. It should have the extreme purity in its material, and if it is not pure, that is going to result in the losses of the light. High melting point of that particular material should be very high. Low refractive index. Now refractive index low ka pahije? Why? That you will understand when we will study the ray theory of light for understanding working of optical fiber. Okay, so losses should be less. So per kilometer 17 dB loss should be there. Again, this wavelength is also very important in optical fiber and its working. जसं आपल्या आता इलेक्ट्रिकल सिस्टमची or whatever is the performance of electrical system, that we are generally taking in terms of frequency. इलेक्ट्रिकल सिग्नलला आपण रेंज कशी करतो अप्लाय? फ्रिक्वेन्सी रेंज मध्ये 1 kilohertz, 2 kilohertz, 3 kilohertz. Similarly, for the optical signal, whatever the its range you are going to decide, किंवा इलेक्ट्रिकल सिग्नल ऍट पर्टिक्युलर फ्रिक्वेन्सीने आपण त्याला स्पेसिफाय करतो. तसं ऑप्टिकल सिग्नल दॅट इज स्पेसिफाईड ऍट अ पर्टिक्युलर wavelength. So what is the relation between frequency and wavelength? Can you tell me any formula which is telling the relationship between the frequency and wavelength of any signal?
2 FM.
Hmm?
2 FM.
That is actually bandwidth. Twice of FM, that is bandwidth of AM. I am asking you, tell me the formula which is giving the relationship between bandwidth and which is giving the relationship between frequency and wavelength of any signal, whether it is inversely proportional or directly proportional. Frequency and wavelength. Okay, that point also you note down in your homework.
Ma'am, inversely proportional आहे.
Okay.
Lambda is equal to V by F.
Relationship between frequency and wavelength, and its formula you search for that.
Lambda is equal to V by F.
Just 1 minute. Just 1 minute, Avdumbar. What? Okay. I am not able to hear what you are saying. काय म्हणताय तुम्ही आता सांगितलेलं?
Lambda is equal to V by F.
Relation. Okay, just Avdumbar, you wait. I am discussing in the class. You okay? Or if you are able to tell right now, you can tell. Yes, girls. You have to write what is the relationship between frequency and wavelength of any signal. That's a formula है जो दोन्ही मधलं relation indicate करतो. So you tell me that formula. You search and tell me tomorrow. At I will ask. Now it is clear. So historical development, in that we have seen this particular things, and in 1970 onwards, low loss optical fiber was developed. Obviously that loss parameter, that is very important. If though some material is very good, it is able to transmit for long distance, it is having low cost, though all the parameters are okay, but loss is very important. Low loss fiber should be developed. So ultimately in 1970, these fibers have been developed which were able to transmit the signal with comparatively very less losses. And in nowadays, whatever fibers are used, those are having the attenuation constant as 0.35 dB per किलोमीटर. इथं बघा इनिशियली जे डेव्हलप झाले होते त्याच्यामध्ये किती लॉस होता, 17 dB per kilometer. So through this development, it has reached to this 0.35 dB per kilometer. Means that much experimentation was done, and currently whatever the fibers we are using, those are having. So this question can be asked in oral also. What is the usual range of losses for the fibers which we are using currently? So it is approximately from 0.2 dB to 0.35 dB per kilometer. Okay, so that is the loss specification for current fibers. Okay, so this is the historical development. So again, this is for just your more information. You can refer this chart. 1980 जे फायबर डेव्हलप झाले त्याचे स्पेसिफिकेशन काय होते, वेवलेंथ किती होती, बिट रेट, व्हॉट वॉज द बिट रेट, video voice channels per fiber. Here that how many voice channels you were able to connect, 672. Here it was increased, and here if you see 1997, here it is 5,16,000. So like that it was developed. Regenerator span, regenerator म्हणजे काय, or that repeater. So if suppose I have to transmit one signal from this point to that point, so in between I am placing the repeaters. Repeater काय करतो, same signal it is again transmitting. Same signal म्हणजे इथून तिथपर्यंत डायरेक्ट सिग्नल ट्रान्समिट होत नाही, बट थ्रू रिपीटर्स. तुम्ही रिले गेम खेळा असाल ना लहानपणी, so you are passing that thing to next person, that next person passes it on, like that. Similar function it is there for repeaters. Okay, so number of repeaters system मध्ये कमी पाहिजेत का जास्त पाहिजे? Suppose one system is there in this class which is having 5 repeaters, and in that class 10 repeaters. So which one is good?
What
Same signal as transmit होतोय. Okay, repeaters, I have asked the question, number of repeaters for if you are designing any system, the number of repeaters in the system should be less or it should be more to have the optimization. Number of repeaters वाढले तर काय होईल तुमच्या सिस्टम मध्ये? Signal will be able to get transmitted but through less number of repeaters. म्हणजे चॅनलच जर तुमचा चांगला इफिशियंट असेल तर number of repeaters required will be less. If channel is having more losses, then you need more number of repeaters. If you use more number of repeaters, the system will be complex. So the regenerators or repeaters should be less. त्यामुळे इथं बघा हिस्टॉरिकल डेव्हलपमेंट मध्ये 1980 मध्ये किती किलोमीटर नंतर एक रिपीटर लावावा लागायचा, 7 किलोमीटर. बट थ्रू द डेव्हलपमेंट हिअर इट चेंज फ्रॉम 7 to 50. म्हणजे इथं जर 7 किलोमीटरला एक लागत असेल तर इथं 50 किलोमीटरला एक लागला. म्हणजे इफ यू कन्सिडर अराउंड 7 रिपीटर्स वेर reduced or around 6 repeaters were reduced. Then now it is range, it is 360 kilometer in 1997. So these are all the developments. Now we will see the advantages of optical communication. Now I am teaching completely from your offline point of view, your exam. Up till now you have not written any theory paper. So only MCQs were there. But now point wise I will discuss. Now in the exam the question it is asked at least for 4 marks. Explain the advantages and disadvantages of optical fiber. Okay, so we will first discuss the advantages. So can anyone tell what are the advantages of optical fiber? पहिला advantage काय आहे त्यातला? It is having
Optical fiber using long distance communication.
okay, loss is less, so it can be used for long distance communication. That is first point. Then second, speed is more. Then low
Transmit
Hmm.
transmit the massive amount of information at one time.
It transmits the massive amount of information at one time. What do you mean by that massive information? Can you tell?
Massive means, madam, the big data, or at a time we can send more and more data.
Okay.
That is nothing but.
Okay. So any other answer in the class? Okay. So there are so many advantages. We will go one by one. So first one, it is high information carrying capacity. Information carrying capacity, it is more. So lot of information it can carry as compared with the electrical signal or as compared with the coaxial cable. So a valid comparison would be on the basis of cost per meter per telephone channel rather than just cost per meter. So if you see the number of channels which can be connected at a time by optical fiber as compared with the coaxial cable, then that is obviously more. म्हणजे फक्त टाइम वाईज किंवा मीटर वाईज आपण त्याची कॅपॅसिटी बघत नाहीये, तर हाऊ मेनी चॅनल्स इट इज एबल टू connect at a time, that is also involved in this high information carrying capacity. Okay, so information carrying capacity is more in optical fiber. Obviously this comparison is with respect to which channel? Previous coaxial cable. म्हणजे आधीच्या ज्या आपण ह्या सिस्टीम बघितल्या ऑप्टिकलच्या आधीच्या, दिस ओपन वायर सिस्टीम, कोएक्सेल सिस्टीम, ह्याच्या अगेन्स्ट आपण कंपेअर करतोय ऍडव्हान्टेजेस. सो as compared with the previous system, the information carrying capacity it is more for optical fibers. Then resource plentiful. Plentiful means what? In a sufficient range. The basic materials are either silicon dioxide for glass fibers or transparent plastic. म्हणजे जे रिसोर्सेस लागणार आहेत ऑप्टिकल फायबरच्या मॅन्युफॅक्चरिंग साठी, दोज आर अवेलेबल विथ अस ऍट सफिशियंट अमाऊंट. फॉर एक्झाम्पल एखादी गोष्ट खूप चांगली आहे, पण for fabricating that, if you are not having easily that material available, then obviously that is very difficult to design. Suppose तुम्हाला खूप लांब डिस्टन्स वरून ते मटेरियल इम्पोर्ट करावं लागत असेल, then probably you will not prefer. For your simple example you can take, if you have to start something new, or if you have to start some business, or if you have to start some your own firm, there also easily generally we are checking the availability of the components. जे resources आपल्याला easily मिळू शकतात त्याच मेथड कडे आपण प्रेफर करतो. So for manufacturing of this optical fiber, which materials are required? Mostly either glass or the plastic. Glass is nothing but this silicon dioxide for glass fibers, that is available in a sufficient amount. Then second, this is the second advantage. Then okay, you just tell me when time will be over. How many minutes are remaining? 15 are remaining, no? Okay. Then next is less attenuation. Now this attenuation word stands for losses. You can write down that meaning if you want. This attenuation stands for the losses. So you just write down whatever I am telling. Heading you give as advantages of fiber communication. Call. Okay, later. Advantages. Okay, I will tell. Advantages of optical. Advantages of fiber communication. Like that heading you give. हा पण बघतोय ना आपण advantages of fiber communication. Advantages of fiber communication. Then under that You just write that basic points. First, high information carrying capacity. Those who are attending offline also, please write down this, online also, please write down these things. You give the signal. Okay, lot of answers are there in the chat box. Okay, good. You write down the heading. First, high information carrying capacity. Don't write explanation, just write the main point. High information carrying capacity. Second, resource plentiful. Resource plentiful. Then third, less attenuation. Third point you write down, less attenuation. Now less attenuation. So attenuation meaning you were asking. So attenuation, the word technically stands for the meaning as loss. आता वेगवेगळ्या टाइपचे लॉसेस आहेत. स्कॅटरिंग लॉस इज देअर, बेंडिंग लॉस इज देअर, absorption loss is there. By considering all the losses present in the optical fiber, whatever total loss you are going to consider, that is denoted by this word called as the attenuation. म्हणजे attenuation consists of impact of all the losses involved in the optical fiber. Loss A, loss B, loss C. या सगळ्याचा मिळून जो काही कंबाईन लॉस आहे दॅट इज नोन बाय द नेम एज अटेन्युएशन. त्यामुळे जनरलाइज्ड टर्म काय यूज केली जाते लॉस रिप्रेझेंट करण्यासाठी फायबर मध्ये, दॅट इज अटेन्युएशन. सो लेस अटेन्युएशन मीन्स लेस ट्रान्समिशन लॉसेस. आणि हा अटेन्युएशनचा जो कन्सेप्ट आहे दॅट इज डिनोटेड बाय दिस टर्म विच इज नोन एज अटेन्युएशन कॉन्स्टंट. अटेन्युएशन कॉन्स्टंट आहे हा इथं 0.3 dB पर किलोमीटर. याचा अर्थ काय होतो, पर किलोमीटर मध्ये किती डीबी लॉस आहे, 0.3 dB. सपोज दोन फायबर असतील, वन इज हॅव्हिंग 0.3 dB, 0.3 dB kilometer loss, 0.3 dB per kilometer, and another is having 10 dB per kilometer. Then which one you will prefer? 0.3 or 10? 0.3. Yes, because it is having the less losses. So typical fiber attenuation is in the range of 0.3. आता इथं 0.3 दिलेलं आहे, but usually you can take the range from 0.2 to 0.3 dB per kilometer. Whereas a coaxial cable will attenuate the signal by which amount? इथं बघा तुम्ही 22.6 dB per kilometer. So here if you see किती पट आहे इथं लॉस जास्त बघा. Here it is 0.3 and here it is 22.6. So approximately it is 10 times, you can say, or 8 times. So that much it is more. So this is the third point, less attenuation. Understood first three? Fourth point is greater safety. Heading you write down. Greater safety. Safety means what? Here it is security of the information. Whatever information is transmitted through optical fiber, it is not easy to detect that particular information. That's why the safety of the information it is more. Okay. So greater safety. Optical fibers, glass, plastic are insulators. No electric current flows through them. So here you can consider that safety with respect to two meanings. First, safety means by considering that suppose electrical current is flowing and if in some hazardous area is there, light बरेचदा काय होतं, पाऊस आला की तो करंट पाण्यामध्ये उतरतो. So in that case it is somewhat harmful. But whereas if you consider optical fiber, that is totally free from electromagnetic interference. Next there will be the same point also. Here you can see immunity to radio frequency interference. Optical fiber हा glass आणि plastic पासून बनलेला आहे, which is totally the insulating material. So they are not carrying any kind of electrical current. That's why though it is a rainy situation or though it is somewhat atmospheric odd condition is also there. There also you can use this optical fiber for better safety purpose. Okay. So greater safety, that is one meaning of this. And another meaning here it is here also. This one I was explaining, high security. Security because आता लाईटच्या फॉर्म मध्ये इन्फॉर्मेशन आहे तर ती इझिली आता एखादा लाईट रे तुम्हाला दिसला तर युजली it is very difficult to understand what is present in that particular light signal. That's why security point of view also the optical fibers are more good as compared with the coaxial cables. Okay, this safety I was discussing about the no any electrical current किंवा shock वगैरे कोणाला इथं बसू शकत नाही कारण that is not having any electrical conductivity. So then next is immunity to radio frequency interference. So fibers have excellent rejection of radio frequency interference caused by radio and television stations, radar and other electronic equipment. So radio frequency range is high or low? I have told you previously also. Radio frequency, when we use that word RF, so that stands for high frequency or less? High frequency. And what is the acoustic frequency range? Acoustic frequency range. Which is audible to human being. What is that frequency range? Yes, anyone from this side? Acoustic.
20 hertz to 20 kilohertz.
Yes. Okay. From the class. Tell. Acoustic frequency range, which is 20 hertz to 20 kilohertz. आपल्याला त्याच फ्रिक्वेन्सी रेंजचा आवाज आपण ऐकू शकतो. त्याच्यापेक्षा कमी असेल तर आपण ऐकू शकत नाही. And if it is more than that, we are not able to bear that sound. Okay. So acoustic frequency range. There are different range of frequencies we have seen in electromagnetic spectrum. But when we say this RF, that is having very high frequency. So fibers have excellent rejection of radio frequency interference caused by radio and television stations. So because of that, whatever the radio frequencies are used. And now as this reference has come, I will tell you something related to that harmful waves which may affect in negatively on your body. आता आपण पूर्वी बऱ्याच जणांकडून तुम्ही ऐकलं असेल की mobile we should not keep in the pocket because that waves whatever are coming, or we should not keep it near our body because the rays which are coming from that can harm to our body. That is simple example. आपल्याला जे माहिती आहे ते. But if you consider the various antenna systems, obviously now antenna systems they are using very high frequency. मग ते जे अँटिना फ्रिक्वेन्सीचे सेंटर्स वगैरे असतात ट्रान्समिटिंग वगैरे, usually that is located far from the city because whatever is the waves they are emitting that are having very high frequency signals and that may have negative impact on the body. So radiation जे आहे high frequency signals, many times that is creating the harmful effect. That's why many regions whatever are the RF operators किंवा RF frequency वरती ऑपरेट होणारे जे डिव्हाइसेस आहेत, that kind of devices or that kind of firms they are very outside located from our local region. Okay, so that also just for your interest, that is one of the interesting topic you can read just for your understanding. Radiation pattern बरेच आपल्या बॉडी साठी हार्मफुल असतात, त्यामुळे ते whatever are that buildings, either they are at very height of that building, it is very high. जे काही रेडिएशन येतील ते युजली आपल्या लेवल पर्यंत पोहोचत नाहीत, और or they are located very outside from the local region. Okay, so this immunity to RF interference, it is there for the optical fibers. Okay, then immunity to electromagnetic interference. So electromagnetic interference that is caused by natural phenomena such as lightning, sparking. आता एखाद्या ठिकाणी means electrically that atmosphere is hazardous. Suppose there is sparking taking place, lightning. आता वीज वगैरे चमकते तेव्हा आपण जनरली इलेक्ट्रिकलच्या ज्या वस्तू असतात that we are making off because that may pass suddenly the high current or that may spoil the particular device. So that is called as electromagnetic interference. Because of high magnetic field, the device may get damaged, but these optical fibers are immune to the electromagnetic interference. Okay, so that is the next advantage. Advantages heading लिहून घेताय ना तुम्ही. Immunity to RFI and immunity to EMI, that is electromagnetic interference. Then next, no crosstalk. Crosstalk means what? Suppose one cable is carrying one signal, another cable it is carrying the signal. So when the signal get mixed with each other, that is called as the crosstalk. So crosstalk, it is usually avoided in the optical fibers. Okay, so the optical wave within a fiber is trapped. None leaks out during the transmission to interfere with signals into other fiber. Jar optical fiber structure बघितलं तर core is there and that is surrounded by cladding. So whatever is the light that is transmitting through the core only and it is not entering into cladding. The cladding ला तुम्ही protective layer for core, like that also you can term for the cladding because it is basically protecting the light transmitting through the core. मग तिथं ते आहे रिफ्लेक्शनच होतं त्यामुळं कोर मधून जरी लाईट बाहेर जायचा प्रयत्न केला लाईटने तरी कोर क्लॅडिंगची जी बाउंड्री आहे जसं मी काल तुम्हाला एक्झाम्पल दिलं की सपोज हा कोर आहे ऑप्टिकल फायबरचा, दिस क्लासरूम इज and that wall it is acting as a core cladding interface. That side if it is cladding, so this light ray when it strikes on the wall, रिफ्लेक्शन मुळे काय होईल परत तो कोर मध्येच येतोय, तो क्लॅडिंग मध्ये जातोय का? क्लॅडिंग मध्ये गेला तर आपण काय म्हणू त्याला? रिफ्रॅक्शन. बट the basic structure is itself made that total internal reflection only takes place. त्यामुळे तो कोर क्लॅडिंग इंटरफेस वरती स्ट्राइक झाला तरी अगेन इट इज कमिंग बॅक इनटू द कोर like that. So that we will see in the ray theory of light. So that's why it is not possible for light to get escape from the fiber and there is no question of the cross talking. Okay, then next is higher security. Security it is more because you cannot trap what information is present in the light form. So next advantage is small size and lightweight. So it is having small size and its weight is also less. जर तुम्ही बघितलं फायबरचा डायमीटर that is in terms of micrometer or some millimeters. So it is 125 micrometer. त्याचे डायमेन्शन जे आहेत रेडियस वगैरे that are also in terms of micrometer and weight it is also very less. So that is next advantage, small size and lightweight. Obviously it will be easy to implement in any system. Less corrosion. Corrosion means what? Corrosion चा अर्थ काय होतो? झीज किंवा गंजणे. जर मेटॅलिक मटेरियल असेल तर ते पाण्याच्या किंवा केमिकलच्या कॉन्टॅक्ट मध्ये आलं तर त्याला करोजन होऊ शकतं, बट इट इज नॉट ऍप्लिकेबल फॉर ऑप्टिकल फायबर्स. नेक्स्ट, लेस टेम्परेचर सेन्सिटिव्ह. टेम्परेचर इज द पॅरामीटर. टेम्परेचर लेस सेन्सिटिव्ह मीन्स व्हॉट? टेम्परेचरचा त्याच्यावरती जास्त इफेक्ट होत नाही. इफ इट इज sensitive to temperature, because of temperature its working will get affected easily, but as it is less temperature sensitive, glass fibers can withstand म्हणजे काय? टिकून राहणे. Glass fibers can withstand extreme temperatures. Glass fibers are unaffected. Usually because of high temperature, these glass fibers are not affected. Okay, so this is about the advantages of optical fiber. Okay, so now we will see the disadvantages also. So time is over. Okay, so that point we will see in the next lecture. So those who are present in the online, please type your roll number in the chat box. And then you can leave the, okay, don't leave the meeting till I tell. We would take that. Screenshots you take for attendance. Just wait 1 minute.